Construction and Loci. So, the objective for today's lesson, or the objectives, sorry, are we're going to first of all teach you how to construct triangles, because we're familiar with triangles. We've been doing triangles ever since we started this whole Unit 3 stuff. And we're also going to teach you to draw other shapes. And to draw these shapes, we're going to use a combination of rulers, protractors, and so on. And that's what the first two objectives are all about. The third one is this word loci, this set of rules for drawing. And this is where you get to do a plan of a garden, and you can't plant the tree within half a yard of the wall and within 2 yards of the pond and all that sort of stuff. And you're going to shade areas that satisfy sort of sets of rules. And that's what loci are. The last one is a throwaway one. So before half term, at the end of the lesson, I put up 2 words and I said, for your learning outside the classroom, that's why it's got the asterisk, I wanted you to find out about the words similar and congruent and what they meant. And if you came back with that knowledge, we'd speed through that last bit. And if you didn't come back with that knowledge, we'd have to spend a bit more time going through it. Okay? So there's 2 questions here I'd like you to answer for me. The first one involves what they call a bit of deep thinking in maths. I'm not just going to ask you for an angle. What I want you to do is tell me what a scalene, equilateral and isosceles triangle all have in common, and I want you to tell me what's different about them as well. Okay, that involves a bit of deeper thinking on these shapes. The second one is, I want you to tell me what angle that question. Okay, these were the angles that we were doing a few weeks ago. These are some of the rules that we learned. We learned about corresponding angles, we learned about the angles inside a triangle, and we learned an angle on a straight line. If you can't see stuff like this, you need to go back and practice your angles, because this is the sort of question you're going to get. Today, we're going to teach you how to draw angles, okay, which is why that's relevant today. So let's get constructing then. It's a real hands-on lesson for you today. And we're going to start off by drawing triangles, because this is the thing that you've become most familiar with over the last few weeks, believe it or not. Okay? So, when they give you triangles to draw, they'll give you a certain amount of information. And that information will involve either angles and or sides. So they'll give you a combination of angles and sides and say draw a triangle using this information. So they could give you 2 sides and an angle, and that's called side, angle, side, or SAS if you're that way inclined, okay? They could give you just the length of 3 sides of a triangle, and they call that side, side, side. Or they could give you 1 length of a side and 2 remaining angles, and they call it angle, side, angle. So there's you'll see them in textbooks written SAS, SSS, and ASA. All that's telling you is the information you're going to be given is this, now go and draw your triangle. And that's what we're going to practice for the next half hour, 45 minutes or so, okay? I'm going to give you information on those 3 in that format, and you're going to show me you can draw those triangles, okay? But I will give you a demonstration of each and show you how to do it. So this is an example of information where I've been given 2 sides and 1 angle. So that's SAS, side, angle, side, okay? So how would I go about constructing this triangle then? What's the first thing I could do?
The base. The
base. So we'll take the longest one. The base is generally the longest, isn't it? So if I take my base and I stick my base there, I've drawn my baseline. Then what would I do to construct this triangle?
Then you get the 7 centimetres and draw it up then, so you can construct your angle around that.
Would you take your 7 centimetres first, Sam? What would you do?
I don't know if I'm right, but you put your point on one of the ends.
So you put your, let's get our protractor down. Is that what you mean when you say
your
point? Yeah,
and then
let's
do
extend it out.
65 degrees and do like a little
good
dash thing.
So if that's 0, 10, 20, 30, 40, 50, 65, so put a little notch at 65. Let's shrink this down and get rid of it. So I've gone from there and I've measured 65 degrees.
And then to do that nick,
yeah, I'm going to draw my 7 centimetre line so that it goes through my nick. See what I've done there? So I know that this angle here is 65 degrees. Does that make sense? So you draw your baseline, you measure your angle, you draw your next line. But I haven't got a triangle yet, so what do I need to do?
just join it up.
To join it up. Okay, just join that end to that end, and that completes the triangle. When you do triangles like this, write down the information that they've given you. So they gave us 10 centimetres, they gave us 7 centimetres, and they gave us 65 degrees. You don't have to write this length down unless they ask for it. You don't have to measure the other two angles unless they ask for it. But just label it with the information they've given. Now, when we started Unit 3, I told you about letters representing things. In Unit 2, letters represented numbers because we didn't know what the numbers were. In Unit 3, the letters represent a point, a line, or a shape, or specifically an angle. So if they say to you, draw an angle D, a triangle DEF, the corners are labelled DE and F. Okay? When they tell you DE is 5 centimetres, they're telling you the length between the corner of D to the corner of E is 5 centimetres. D to F is 3 centimetres, and the angle EDF is 40 degrees. So where's the angle sit at 40 degrees? Which one?
ED line.
The angle sits, right, and you've got to remember this, at D.
So
Okay.
the one.
It's the middle one, that's where the angle lives. So if you look a little sketch, if you drew a little sketch of what they've asked me for, they've told me D to E is 5 centimetres. They've said the angle at D is 40, so at that end I have to draw my 40 degree angle. And then D to F is 3, so I measure 3 centimetres that way, and then I join the triangle up. Okay? And that's what I'd like you to try now. So I'll show you the 3 bits. Draw D to E first, measure your angle of 40 degrees, draw your 3 centimetre line exactly on that 40 degrees, and then do it through. So your example is, draw a triangle for me, JKL, with a side JK of 9 centimetres, KL 7 centimetres, and the angle JKL of 30 degrees.
Is it 9 centimetres JK?
JK is 9 centimetres, but which end of the line is J and which end is K? What tells you? Where's the
That
angle?
one.
Where's the angle of 30 degrees? Yeah, so which letter has got an angle of 30 degrees, did we say? Last
K.
slide, yeah, K, it's the middle one. So the angle has to be at K. So when you've drawn your 30 degrees, that has to be the K end. Does that make sense? Yeah? Happy with that? You've got JK. Right. Yeah. Okay, so you've got JKL. Happy? Label it JKL. Fantastic. Right. Let's move on to the next type of triangle then. I've got 3 sides. How would I construct a triangle to draw these 3 sides?
You put the base down first.
Let's draw the baseline. That's my baseline. Fantastic. I'm using the longest one as the baseline. Then what am I going to do?
You just simply connect it up.
Connect it up, right? So if I stick, let's just say 8 at this end and 5 at that end.
Done.
What do I got to do? Yes.
Is this the one where you get your compass?
Brilliant.
And
Right.
you put it on.
Get my compass. So you know what your compass is? Sharp pointy thing? Yeah?
You measure your compass to 8 centimetres.
I measure my compass to 8. Brilliant,
With
Sam.
a little dash, yeah.
I put an arc on
And
there.
You do it to the other side
And then I get my compass,
and do that at 5 centimetres.
set my compass at
And
5
then do your arc.
and draw an arc.
And then just join the lines to the points.
And where those 2 arcs cross, that's exactly 8 centimetres and that's exactly 5 centimetres. Yeah? So it's like a drawbridge. You see, when I first drew it, they were nowhere near each other. By doing it with a compass, you're doing like a drawbridge and you're saying, where do they touch? And they touch where those 2 arcs cross. Does that make sense? Let me show you another one then as an example. I'll do this one with you. Right? So I've got to draw a triangle, 6, 4, 3. So we'll do this together on the board. So what would I draw first?
6 centimetres.
6 centimetres. So let's draw a line of 6 centimetres. And then what would I do?
You put 4 down first.
Put 4 down. But how am I going to put the 4 down? What am I going to do with the 4?
Put your
Compass. So you set 4 centimetres on your compass and you draw an arc of 4 centimetres from this end. And then what am I going to set on my compass?
3 centimetres.
Set 3 centimetres on your compass, put the pointy bit at the other end, and draw an arc of 3 centimetres. And now, where those two cross, you know from here to here is exactly 4, and you know from there to there is exactly 3. Does that make sense? I will get you to draw this one then. Draw a triangle for me. I want it to be 10, 8, 5 triangle. So what you should have done, draw your baseline of 10, set 8 centimetres on your compass and draw an 8 centimetre radius. Then set a 5 centimetre radius and draw a 5 centimetre radius, and where they cut, that's your 10, 8, 5 triangle. And those blue and green construction lines you leave. You get good marks for those. Don't be tempted to rub them out. Yeah? Good. Let's look at the next type of triangle, and this is an ASA. In other words, you've been given 2 angles and only one side. So how would I construct that then?
You do it exactly the same as the first one, don't you?
So put your base in, and then what will I do?
Get your compass and put 30, and then draw the...
Not your compass.
Your protractor.
That's it. So get your protractor and measure your 30 degrees with a little nick up that end.
And then do you do the same for 50, and do you draw the lines?
Good. At the other end, measure 50 degrees with your protractor and put a little nick.
And then do you just draw your line straight?
Draw your lines almost to infinity. So just when you've got your angle and your little nick, you just draw it through your nick, which is here. Okay? And then through your 50 degrees, just draw it through your nick, which was there, and that's your 10, 30 degree, 50 degree triangle, if you see what I mean. And the fact that they cross, again, let them cross. Show the examiner that that's what you've done, okay? So where they cross and they go on beyond where they meet, leave it, because that's good. It shows them how you've constructed it, okay? So have a go then. Draw a triangle ABC, where AB is 7 centimetres, ABC is 35, and BAC is 55. You draw A to B. The angle at A is 55, so you'd measure 55 and draw a line up and label that 55 degrees. For B, you'd measure 35 and draw a line up, and then you put a little C up there.
Would you not write 7 centimetres underneath A?
Yeah, and you would, 7 centimetres, there you go. And that is every mark. Okay? That's what your perfect triangle from that information should look like. So the angle at A is 55. See what I'm saying,
the
Amber?
way around.
Mm-hmm.
Sorry?
I put 35 there and B.
Doesn't matter.
Right.
It's the same triangle, but it's like if I put a mirror here, what you're saying is you went B, A. Well, A is still 55, so that's 55. B is 35, so that's 35. You draw it up like that, and that's C, and that's 7 centimetres. It's the same triangle, it's just flipped. And even the other day, we had somebody who drew it up here and did it upside down. It doesn't matter, it's always the same triangle, it's just in a different place, yeah? You're just moving it around. Which is where similar and congruence come in. Okay. We've done one of them, we won't do another one. So, equilateral triangles, a very special type of triangle. Because, what? What's so special? And the full sides are the same? Not just the same, they're all...
Equal.
Not just equal, they're a number. What's the number?
60.
They're always 60, right? So with an equilateral triangle in construction, it's one of their favourite questions to ask you, because they can give it to you in lots of different ways. They can say, draw an equilateral triangle with a side of 8 centimetres. So if I was going to draw a triangle of 8 centimetres with 8 centimetres on all the sides, how would I draw that? We've already done it.
Get your wheel and just try it.
No?
No, you use your this.
Compass. Yeah, we're learning the words. It's
Draw
good.
8 centimetres.
Yeah, and you measure out. So you've already drawn a line of 8, so you don't have to put your compass on your ruler. You just put the point there and the pencil there and draw a big arc. And then put the pointy bit at the other end and draw another big arc. And there to there is exactly 8, and there to there is exactly 8. So I've drawn the perfect equilateral triangle. But what else have I drawn? What is another property on there I can put in straight away? the angles are all... Can you see that? By doing that. So, what they can also do with equilateral triangles and ask you to draw equilateral triangles is they might not even give you the length of a side. If I just get rid of that 8 centimetres and we ignore that for a minute, they could just say one of two ways. They could say, draw an angle of 60 degrees. It's one of their favourite. They'll say, here's a line on the sheet of paper. And they will say to you, on there, draw an angle of 60 degrees without using a protractor. How would I do that?
Okay.
Sam?
Is that by measuring that line?
Don't have to measure it.
Or just
Good.
do the same way?
Brilliant. So I don't care how long the line is, it's irrelevant. I can just get my compass, stretch it out for the length of the line, draw an arc. Put the point on the other end, draw another arc, and then that line and that line are exactly the same as whatever that line is. But, more importantly, I've drawn the perfect 60-degree angle. Does that make sense? So it's another way of getting you to draw an equilateral triangle or draw an angle of 60 degrees. They're the same thing. So when you see a question with the number 60 degrees in it, big alarm bells go off. You're thinking equilateral triangle, you're thinking this is how I draw 60 degrees. Okay? So the two go hand in hand. So whenever you see 60 degrees somewhere, big alarm bells. Equilateral triangle, this is how I draw it. Okay? Don't say you haven't been warned. We'll not do that. I'll let you draw one then. Draw an equilateral triangle for me, 9 centimetres in length. Right, what I'm going to give you now is I'm going to give you a chance to practice each of those again, but you're going to practice it by choosing a category at random. So, section A, choose one of the 3 triangles in section A, then choose one of the 3 triangles from section B, and then choose one of the 3 triangles in section C. What we'll do before the break then, so that's specifically triangles, so I'm going to show you how to draw a couple of other things, okay, that will help you when we come to loci. The first thing I'm going to teach you to draw is how to cut a line exactly in half. So if I've got a 4 centimetre line here, using my compass only, I can cut it in half. Anybody seen this before?
Do you put it 2 centimetres and you do it round?
Sort of. You don't actually have to measure it. If you do 2 centimetres, you don't want to measure anything. Without measuring anything, using a ruler or anything, I can cut this line exactly in half.
Yes,
Sam, remember how we do it?
Do you nick at the top?
Good.
Bring it round to it at the bottom. So it's to the
But to
side,
do my nick, how do I set my compass?
to the middle of the line.
No.
4.
4 is okay. Anything above halfway, I don't care what I set it to as long as it's over halfway. If it's halfway or less, what's it going to do? The circles are going to touch or miss. What you want to do is the circles to cross over. So set this distance over halfway. And do you know what? I don't care what you set it to.
So you set it as 4 then, if you want to?
Yeah, but why 4? Just pull it out and just make sure it's over the halfway point. Because when you come to do the next bit, which is draw an arc at the top, as Sam said, and draw an arc at the bottom, you then move the pointy bit to the other end, flip it round and draw an arc at the top and an arc at the bottom. And where those 2 arcs cross, when you join them with a perfectly straight line, it cuts that line exactly in half. And I've not measured anything. I've just used a compass that's set over halfway. I've not measured 2 centimetres and done it. This is what they want you to do in an exam. If they say cut a line in half, they want to see these construction lines and show that you've cut it exactly in half. It's not just cut the line in half. What has it done with respect to an angle here? What angle is that?
Right angle.
It's a right angle. What's the posh word that we use for a right angle? The P word.
Perpendicular.
Perpendicular.
I was going to say that, but it didn't seem right.
Yeah? Remember we covered it a few weeks ago? Perpendicular, we defined it. It's in our buzzwords. If you go to my course, our glossary of terms of buzzwords, perpendicular is in there because we've already covered it. It's sometimes called the perpendicular bisector. In other words, it cuts a line in half at right angles. Okay? Now, I just want... You're happy with what we've done there to cut a line in half? when we go on to loci, we're going to cut things in half. I can cut the distance between 2 points, if I call that point A and point B, or town A and town B, or whatever, I can cut that exactly in half. How can I cut that exactly in half?
Draw a line to A and B, then like do
Don't have to draw a line to A and B at all.
Do the
You
same.
can if you want, but you don't have to.
Do the same as what you've just done.
The same as what I've just done.
Put your protractor on the A.
Put my pointy bit on the A.
Do it like just
Set over halfway
whatever.
as distance. So, oh, that's not long enough. So set over halfway.
Do a nick at both sides.
So draw it down this way and do a nick at the bottom and a nick at the top.
Swap it over.
Swap it over to B.
Do the same.
Do a nick at the top. Ooh. I'll go the wrong. I can't grab that now. Come here. Do a nick at the bottom.
And then just draw your line right through.
Get rid of them. And then I draw from there to there. And that line cuts the distance between A and B in half. So it's exactly like cutting a line in half, but it's cutting 2 points in half. Does that make sense? Yeah? So every point on that red line is the same distance from A as it is to B. So if I said I want to build a shop closer to A than B, I would have to build my shop on that side of that line, wouldn't I? Yeah? Okay. So I'd like you to draw a line AB that is 12 centimetres long, and I want you to chop it in half. Superb. I'm going to teach you how to cut an angle in half now. Exactly in half, without measuring anything. Okay? I've got a random angle here. I don't know, what does that look like from our estimates?
45.
Brill, about 45 degrees, isn't it? I'm going to cut that exactly in half. How am I going to do that then?
Would you do it from the top, that point there?
This top point?
Yeah.
No. Oh, I don't like that point. That point could be anywhere. That could go on for infinity. I'm just interested in this bit here. And the top tip is I've got these. Sam, you remember how to do it?
Yeah.
Go on then.
You put your compass on the point at the bottom.
Put my compass on the point bit at the bottom.
Same as whatever last time. Do it just anywhere past.
Not even that.
Wow.
Set anything. You can set anything on this time. Don't care. There's no length. I don't care how long that is. I can set it there. I can set it there. Don't care. I'm just going to set anything on it.
And then do your nick.
Where am I going to do my nicks?
Through that line there.
Through this line.
And then on the other side.
And I'm going to nick this line. So I'm going to put 2 little nicks in the 2 lines.
Then move your point to one of the end point thingy-bobs.
To my first nick.
And then do your nick, yeah.
In the centre, roughly.
And then
Roughly,
on the
in the
side.
centre. And then
Put it on the other side.
put the compass on the other nick.
Do the same. And then just draw the line straight down the middle through the point at the end.
So from the centre of my angle, through that cross cut, and I have just cut an angle absolutely perfectly in half. What do we reckon? Good, isn't it? How do you know that, Sam?
My share, it's my
There you go.
favourite.
Ah, see, everybody has their favourites. So to cut an angle in half, we don't care what we set on the compass. You can set anything, as long as it doesn't change. Put a nick on each of the 2 lines, and then put the compass on each of those 2 nicks, and put an arc into the centre. So what I'm going to get you to do is I'd like you to draw an angle, DEF of 70 degrees, and you can use your protractor for that. I prepared earlier. Okay, so you draw your circle, you measure 60 degrees to get your first nick, plus your reference, and then you don't have to measure lots of 60 degrees, use your compass. Let's just use the compass here. So I get my compass, I put my pointy bit on the first nick, and then I stretch it out so that it goes through there. Once I've set that length, I don't have to keep measuring 60 degrees because the length is always the same. See what I mean? Yeah? So it's a quicker way of doing it. I don't have to keep measuring lots of 60s. Does that make sense? Let's see. Draw a regular pentagon for me. Good. First 2 objectives complete. Okay, what we're going to move on to now is loci. Don't want you to panic with loci. It's one of those words that you might have come across before that kind of does your head in. If you just think of loci as a line or a region that basically shows all the points that fit a given rule. So some of these construction techniques that you've just learned, and a couple of new ones, we're going to use to draw things where, I don't know, we can't plant a tree within a certain distance of a house, or you want to build a supermarket within a certain number of miles of a town, something like that. So these construction techniques you've just learned, and some new ones, are going to give you all these rules where we can start becoming proper architects. Okay, so you're going to need all of the drawing tools that you've just used. So there are basically 4 rules of loci. Okay, there's a rule for a fixed distance from a given point, which we'll talk about in a second. The second one is a bit more complicated. It's a fixed distance from a line. The third one we've already covered, which is something that's equidistant from 2 lines. What we mean there is something that is the same distance from that line as that line, and we've done it. What have we done that splits those 2 lines in half? Bisected the angle. Remember we bisected the angle? Nick, arc. We did that earlier. That bisects those 2 lines at the same time. So not only does it cut the angle in half, it creates a line that is the same distance from that line as it is from that one. That's what number 3 is all about. So we've actually done number 3.
Can you do it another way? I know it's not the point, but can you do it the other way at the ends of the triangle? On there? Like the bisect from the distance between...
No, because you don't know where these end.
Oh, right, okay.
The idea is you're a set distance from a given point. If you do it from that end and that end, it doesn't work because these are 2 different lengths. Yeah. The whole point is it's referenced from a fixed point. And then the 4th one we've done as well. Equidistant from 2 given points. So if I say I've got point A and point B, how do I draw a line that's the same distance from A and B? Remember how we did that earlier?
Measured the stab thing.
Stab thing, compass.
And then spread it out to that, so it's like half, or just over halfway.
Brilliant.
And then draw your nicks.
So we've done that one as well. So of the 4 techniques you need to learn, we've done 2. The first one's easy. The only tricky one is the second one. So let's look at the first one then. If I said to you, I've got a fixed point. Let's call that fixed point A, because we've got A up there already. I want to draw a line of all the points that are exactly 10 centimetres from A. How could I do that then? How am I going to draw 10 centimetres away from A?
Ruler.
Ruler, and I'm going to measure 10 centimetres, I'm going to go like that. That's 10 centimetres. So that point's 10 centimetres away from A. What other point is 10 centimetres away? Another 10 centimetres?
I know 10 centimetres.
This is the one they always put in a circle as well, I think.
That's because that's what it is. Every point on a circle, on that circle, is 10 centimetres away from that point. So when you're talking about loci, okay, the number of points that satisfy a rule, if I said to you, I want you to draw all the points that are exactly 10 centimetres away from this point, so that's my rule, the points on that circle satisfy that rule. So they are the loci of points for satisfying 10 centimetres away from the point A. Okay? Does that make sense? So if you have a fixed distance from a point, you draw a circle. Yeah? So if I've got Aberdeen and I want it to be, show me all the places I can draw a supermarket that are within 10 miles of Aberdeen, I would draw a circle of 10 miles, and then where can I build my supermarket? Anywhere inside the circle. Yeah? And that's how we use it. Okay? So that's types of loci 1. The second one is the trickiest thing that you're going to do today. Oh, don't worry about that. I've done that already. Okay? The second loci rule is if I have a straight line, and it's slightly trickier to draw all the points that are a set distance from a straight line. If you look at the line first, we kind of went about it the wrong way round. If you look at your line, and you need to be a set distance from that line, you draw a parallel line above it and below it. And then think of the ends of the line as a point. You join the end of your line with a semicircle at each end, and it creates this racetrack. And this is called the loci of points for a straight line. Come across? Okay, so what I'd like you to do is I'd like you to create the loci of points, around a line that is 9 centimetres long, and each of those points needs to be 3 centimetres away from that. That was the tricky bit. So we've already talked about the third type of loci, when we say the equidistant from two given lines. Yeah? All they mean by that is what we did earlier, where you're bisecting an angle. Yeah? So if I get you to cut two lines in half, draw two lines 7 centimetres long and make an angle of 60 degrees and then cut them in half.
Could you go back on?
Oh, sorry.
Right, the definition.
Yeah. So this is loci type 3, equidistant from two given lines. So this word equidistant means the same distance between things. Might be a good word to remember. Equidistant. Okay? I think it comes up in your homework. So equidistant means the same distance between two lines. So I've got one line and another line. We've already used the technique to cut an angle in half. It's exactly the same technique. Yeah? So what I'd like you to do is cut these two lines in half. So draw two 7 centimetre lines at an angle of 70 degrees. And then just chop the lines in half. And then the last one is equidistant from two given points. So remember we talked about point A and point B? How do we split those in half? We don't even have to put a line between them. We just pointy thing, as James likes to call it, more than halfway. Remember that? And then when I join those two, that line is the same distance from A as it is from B. Any point on that line. And that's the locus of points that are equidistant from A and B. Okay? So, plot 2 points A and B that are 8 centimetres apart. You don't have to draw a line between them. You can just label them A and B and then cut them in half. They're the basics of loci and drawing and construction. The next bit is kind of the C grade stuff. This is the tricky stuff they're going to throw at you. And this is where you have to start combining a few rules. Okay? So what I'm going to do is I'm going to give you an example of one first, so that you can understand it, and then I'll get you to do a very similar example. Okay? So let's have a look at this problem then. We've got a garden, A, B, C, D. And in the garden I want to plant some trees. The garden's got a scale of 1 centimetre equals 2 metres. Right? Mary wants to plant these trees. Her house runs along AD, so the line there, AD, that's where her house is. Yeah? And she said that the tree cannot be planted within 4 metres of the house. So what do I have to draw to make sure I don't plant the tree within 4 metres of that?
Shaded in.
Shaded in what? What am I going to look at first of all? What am I going to draw to know that I'm not going to plant it within 4 metres? Sam?
Would you do a line from the line AD
Yeah,
up 4 metres
yeah.
and then draw a line across to say what's that shape from that line above?
So if 4 metres is what in my scale? How
2
many?
centimetres.
2 centimetres. So I'm going to measure 2 centimetres away from the house and put a mark there and there, and I'm going to draw a line because anything to the left of that line is going to be within 4 metres of my house. So my tree can't go in that area. Does that make sense? Yeah? She doesn't want the tree to be within 4 metres of the house. So to make sure we don't plant that tree within 4 metres, we draw that line there, which is at the boundary of 4 metres. Can you see that? Yeah? The next bit is slightly trickier. Let's do the next bit. Mary wants the tree to be closer to D than B. So how can I draw something that is closer to D than B? What have we done?
Would it be the one where you put your compass on the 2 points, draw like a nick in the middle,
Yeah.
draw your line going down the middle and say that anything from that line like this way
Brilliant.
is...
Absolutely spot on. So I've got 2 points. We did it a couple of minutes ago. How do I chop 2 points in half? Remember that one? Nick, 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 nick. So the points I'm interested in chopping in half are D and B. So I'm going to chop those 2 points in half. I don't even have to draw a line between them anymore. What do I set on my compass, James? On my pointy thing?
Just over half.
Just over halfway, and I go nick, nick. And then I go pointy end on the other thing that I'm interested in, and I go nick, nick. And when I draw that line, it's exactly what Sam says. That line represents the halfway point between D and B. So it needs to be closer to D. What side of that green line do I need to be? To the left. So I need to be the left of that line, but to the right of this one. So I can plant my tree anywhere in there. Does that make sense? Yeah? So there were only 2 loci rules there. The first rule was it couldn't be planted within 4 metres of the house. The other one was it had to be closer to D than B. So if you want to see if something's closer to one thing than the other, you draw the bisector, or the nick-nick. Okay? Happy? I'll get you to do one very, very similar. Oh, not that one, this one. So in that example I just gave you, it was the first time for a while that we've come across scales. We covered scales in ratios, didn't we? Because a ratio is a scale. One thing on the map is so many things in the real world. And we covered this in Unit 2 months ago, didn't we? So you're going to see scales again in these drawings, okay? So I want you to do a scale drawing, okay? Tommy's got a rectangular garden, A, B, C, D. And the garden is 12 metres long and 8 metres wide. He wants to plant a tree, funny old thing. The tree has to be 3 metres from the edge CD and no more than 6 metres from the corner B. Use a scale of 1 centimetre to 1 metre to draw where he can plant his tree. So what I'm going to give you now is your loci worksheet. So this is going to put together all your rules, okay? On the first side of the paper are some basic construction techniques that I'd like you to have a go at. And then when you turn the page over, there's a couple of worded questions. So I'd like you to finish with the worded questions, not do them to start with. So do this side first, and just do all the construction techniques. And then on the second side, there's 2 worded questions that we'll save till last, and we'll go through them together because I want to make sure that you understand how to draw these multiple loci. That's constructing loci. Do the rest really quickly. A couple of weeks ago I asked you to look at similar and congruent shapes. What's the difference between a similar shape and a congruent shape?
A similar shape's like triangles as such. It's like all like the same like way, aren't they?
Sort of, yeah.
And congruent.
We'll expand on that.
The definition that I found was similar was where it can resize and obviously move, but congruent can move, has more like symmetry, and there's another definition as well for congruent.
Right. Similarity and congruence, you're going to come across them in the next few weeks, which is why we're doing it now. Similar shapes are the same shape but a different size. Congruent shapes are the same shapes and the same size but moved around, either rotated, reflected or translated. So, when we talk about similar, you've got the same angles but different lengths of sides, okay? When we talk about congruent, it's exactly the same shape, but here I've reflected it, here it's been rotated, here it's been translated and moved over there, okay? So, if we were looking at these, Amber, pick out 2 congruent shapes.
That's it. The yellow.
The yellow.
Yeah.
That one and that one. Yeah? Do you agree they're congruent?
They're similar.
They're similar.
Oh,
Same
it
shape,
would be
different
the
size is similar.
green one.
The green one, good. What do we call that shape, Amber?
Pentagon.
Good. That's the lesson you missed a couple of weeks ago, the shape names. So that and that are congruent. They're the same shape, just in a different place. Congruent. Everything is identical, they're just in a different place. James, pick a similar shape for me.
These hearts.
Hearts.
The purple thing.
Purple hearts. You old romantic. 2 purple hearts, congruent. Sam, 2 similar shapes.
The blue stars.
Blue stars, that one and that one are similar. Same shape, but a different size. Okay? That's all there is to it. And we're going to come across that in the next few weeks. Good. Any questions on what we've covered today?